Today, we're going to cover reflection and refraction vectors. Let's go. So in today's video, I'm going to explain what reflection and refraction vectors are, and then I'm going to show you how to create and use them in both Unreal and Unity. Before I get too far into this, it's important for me to mention that most modern game engines have reflections built into them. If I want to see reflections on my surface, I can just set my color and my metallic to 1, and I can set my roughness to 0, and bingo, I have reflective material that reflects the environment. The engine is doing a lot of work under the hood for me in order to produce this effect. And what I want to do in this video is show you a little bit about how that works and what's happening. This will both help you understand what's going on and allow you to create your own custom effects beyond what the engine already provides. So let's take a look at a diagram to understand how reflections and refractions work. So here we have a surface, and the direction that the surface is facing is represented by the surface normal, this red arrow here. And the direction that we're looking at the surface in, also called the camera vector, is represented by this green arrow. So we're looking at the surface in this direction. So what do we see when we look at the surface? Well, if we want to know what's being reflected on the surface, we need to create a reflection vector, which is basically our view direction vector mirrored around the surface normal. And then we can use that reflection vector to look into the environment to see what's over there in that direction. And in our examples today, we're going to be using a cube map to represent the environment. Similar to the reflection vector, we can also calculate a refraction vector. This vector represents how much the light is bent when it travels through the surface. In order to calculate this vector, we need to know the index of refraction for the material that we start out in, which is usually air, as well as the index of refraction for the surface that we're hitting, which is usually something like glass or water. I'll explain more about that when we make the refraction shader, but just like with reflections, if we use this refraction vector to sample a cube map, we'll be able to see the result of refraction on our model. All right, let's switch back to Unreal and take a look at how we can use this in a shader. So here we are in Unreal, and we have our reflection vector node. We can get one of these just by opening up our searcher and typing reflection and adding reflection vector WS. And the WS stands for world space because we're calculating our reflection vector in world space. So in our diagram, in order to calculate the reflection vector, we needed both the camera vector and the normal. But in this case, our reflection vector node is just using the camera vector already from Unreal, so we don't need to supply that. We just need to give it the normal. So let's search for our normal. And in our case, we're going to use the vertex normal world space, but we could also use the pixel normal for this. So let's pick the vertex normal world space and plug that right into our custom world normal here. And so now we've computed the reflection vector. And if you want to take a look at what that looks like, I can just wire that into color. And you can see that it kind of calculates some crazy looking colors there. But what we've done is calculated the direction of reflection. Now in order to actually see reflections, we need to use a cube map. Unreal has cube maps built in that it uses if I set my roughness down to 0 and I set my metallic to 1. But in our case, we're going to be using a custom cube map. And so I'm just going to add a texture sample here. And then I'm going to come over here and select a texture to sample. What I can do is just pick I can type cube in the search, and all of the cube maps here have been named so that they have cube in their name, or their format says texture cube. And so I can find all of the textures that are cube maps. If I want to use the one that's in use by the preview, I can pick this one called Epic Courtyard. This is a cube map that was created at the Epic Studios in North Carolina. Alright, so I'm going to wire my reflection vector into the UVs of my texture sample node here. And with a cube map in my texture sample, now if I wire the result of my texture sample into base color, you'll see that now I have a reflection of this Epic office environment on my model. And this looks exactly like it would if I were to wire, just like I had before, if I were to set my base color and my metallic to 1, and then also set my roughness to 0. Now I'm sampling the cube map that the engine automatically creates. But if I use my reflection vector to sample this texture here, now I'm actually sampling the cube map that I choose. And so I can use this technique to create custom reflection effects that don't match the environment at all. So let's take a look at another example. I could choose some different cube map here just by typing cube in the search. And here is kind of foresty looking environment. But you can see that it no longer matches the environment that my object is in. So if I want to use this to create some kind of a reflection on my object that doesn't actually exist in reality, I can use the reflection vector plus a texture sample with a cube map in it to create all kinds of custom effects that don't exactly match what the engine normally provides. And so again, just to make it clear what's going on, my view vector or camera vector and my normal are being combined together in the reflection vector to calculate which direction the reflection should be coming from. And then that direction is being used as a lookup into my cube map, which represents the environment around the model. And then I get the result that I get is the color of the reflection. Then I can pass that into base color. I could also use that as the emissive as well if I wanted to create a reflection that didn't have any lighting on it. Okay, so that's how the reflection vector works. I can calculate my reflection vector and then use that to sample a cube map. Well, let's take a look at refraction. So with the refraction node, you can see I have this input called ray direction. And if I want to compute a refraction that looks like I'm looking through a glass object, for example, then my ray direction is the camera vector. So let's bring in one of those. So I'm going to look for camera direction vector, and I'm going to pass that into my ray direction. Then it also asks for the surface normal, and again, just like with the reflection vector, I can pass this the vertex normal or the pixel normal. Either of those will work. So I'm going to pass in the surface normal. And now it asks for the refractive index origin and the refractive index target. So in order to understand this, I need to look up these values. Now, if I just mouse over this, it says the default value is 1 for the refractive index origin. And the default value for the refractive index target is 1.33. So it says it's defaulting to the index of refraction of 1.33 for water. So this is assuming that the surface that I'm hitting, this sphere object here, my preview object, is made out of water. Now, if I wanted this to be glass or some other object, I would need to look up the index of refraction for that material. So let's take a look at that really quick. All right, here we are on Wikipedia, and there's a really convenient list of refractive indices. So if I come down here, we can take a look, and it says the refractive index of air is 1.000293. So that's pretty close to what we had as a default in Unreal, which is 1. Then if we come down here, we can see that the refractive index of water is 1.33. And scrolling down a little bit further, we can find plate glass, which is 1.52. So let's switch back to Unreal, and I'm going to put in 1.52 as our refractive index. So our refractive index origin is going to be a value of 1. And then our refractive index target is going to be a value of 1.52. Okay, so let's wire this in. And now we have a vector. And this is our refraction vector. And remember, this is basically our view direction hitting the surface and then getting bent and going through to the other side. So what we're going to see in this case is the other side of the forest as if we were looking through this sphere, if it were made out of glass, to what was on the other side. So now I'm going to take this vector and wire that into my cube map texture lookup. And now you can see it looks like our forest is upside down. Why is that? Well, the light is getting bent as it passes through our glass sphere here. And the glass sphere is acting kind of like a magnifying glass to give us the refraction. And so we have a reflection like this, and we have a refraction like this. And if we want to create something that looks like realistic glass, what we need is a refraction in the middle and a reflection on the edge. So let's take a look at how we can do that. In order to get reflection and refraction, we're going to need to sample our cube map 2 times, once for the refraction and once for the reflection. And then we can blend between these 2 samples using a lerp node. So let's add a lerp. And now we're going to add a Fresnel node. And let's take a look at what the Fresnel node gives us. So you can see that with Fresnel, we're getting white on the edges and black in the middle. And so what we want to do is we want this white to represent our reflection and this black to represent our refraction. So we're going to wire the result of our reflection into the B socket, which is also the result we'll get with white. And we'll wire the result of our refraction into the A socket of our lerp. And then we'll lerp based on our Fresnel. Now if I wire this into our base color, you're going to see that we get reflection on the edges and refraction in the middle. That's a pretty cool result, but we want to tune it just a little bit. So in order to tune this, I'm going to wire my Fresnel term back into base color just so that we can see what's going on. And now I'm going to tune this value called exponent in, and I'm going to set this to 3. And you can see when we do that, we get a little bit more white around the edges than we had before. So now let's wire our lerp back into base color and also into emissive. And now you can see we have a model that has both reflections and refractions. Pretty cool. One thing that's really important for me to point out here is that we're kind of breaking the rules of what we should be doing with the engine. Generally, the engine should be providing all of the lighting information, and that includes reflection and refraction. And what we've done is go around the engine here and provide our own reflection instead. And so you can see that we've created this model that doesn't really fit into our environment. And so if we actually wanted to create something with glass, we would want to use the engine's built-in methods for doing reflection and refraction instead. But what I'm showing you here is a way that you can create something that's custom, something that is not using the engine's built-in reflection system, but is using your own that you've created. And so you can create an effect that does something other than what the engine is intending. All right, so that's pretty cool. Let's switch over to Unity and see how we can get the same effect there. Okay, here we are in Unity, and you can see that I've built a very similar kind of shader. I've brought in my camera node, and I'm using the camera direction. And I've also brought in my normal vector node. Then I brought in the reflection node and passed my camera direction into the input socket, and I passed my normal vector into the normal. And the result of my reflection node is a reflection vector. So then I created a sample cube map node. Here is a sample cube map node. And then I grabbed a cube map texture, and you can see Unity has several of them built in if you're using HDRP. And so then I passed my reflection vector into the direction socket of my sample cube map. And now I've got a reflection that I can then pass into my base color. All right, so that's the way the reflection works. Now, I'm not able to move the camera in the preview here. I can just rotate my object, but the camera is fixed. So it's not as easy to tell that I'm getting reflections here as it is in Unreal. But I am getting reflections just like I did there. Well, what about refraction? How can I do that in Unity? If I go in here and type refraction, I'm getting this cornea eye refraction thing, but that's not what I'm looking for. I need something that calculates the refraction vector, and I don't actually have a node that does that. So how can I calculate refraction in Unity? Well, I can use the custom code node. So let's type custom, and here Unity allows me to create a custom function. So let's go ahead and do that. I'm going to open up my graph inspector here, and I need to create a couple of inputs. I'm going to create an input for my camera, which is a float 3, a vector 3, and I'm going to create an input for my normal, which is also a vector 3. And then I know that I'm also going to need a value called an ETA, or the refractive index, and so I'm going to call this ETA. And then for the outputs, I need a vector 3, which is the refraction vector. And so now I need the code, and instead of using a file, I'm just going to type a string here. So for the name of my function, I'm going to call it refraction. And then I'm going to say, oh, my output needs to be named refract. So then for my code, I'm going to type refract equals, and then I'm going to call the HLSL intrinsic function called refract. Pretty simple. And the HLSL intrinsic function takes the camera vector that I've created here, my input camera vector, and it takes the normal, my input normal that I've created here, and it also takes the ETA value. Now in Unreal, my inputs needed the index of refraction for air, which was 1, and it needed the index of refraction for glass, which is 1.52. And what an ETA is it's the index of refraction for air 1 divided by the index of refraction for glass. And so I can get that value just by pre-computing it. Okay, so here's my refraction function. This is going to create refraction as if there were a refraction node built into Unity, but I was able to just create one just like that. All right, so I'm going to pass my camera vector into it, and I'm going to pass my normal vector into it. And now I need an ETA value. So I'm going to open up my calculator, and I'm going to divide the value for air by the value for glass. and get a value of 0.65789, blah, blah, blah. So I'm just going to copy this, paste that into my ETA, and now I have a refraction vector. So let's use this to calculate our refraction. Okay, cool. So just like we had in Unreal, now we're refracting through the surface of our object. And if we want to do just like we did in Unreal here, we can sample our cube map twice, once for refraction and once for reflection. And then we can blend between the two of them using a lerp node and a Fresnel. So where it's white, we want our reflections. And where it's black, we want our refractions. And now we can wire this into color. And now we have a nice approximation of a glass object with reflections around the edges and refractions in the middle. Okay, I hope you've enjoyed this tutorial and that you learned about reflections and refractions, and that the engine does them automatically, but you can do them yourself manually like this if you want to achieve an effect in your material that the engine isn't giving you. Thanks a lot for watching, everybody. I really hope this was helpful, and be sure to come back next week for more shader tutorials. And in the meantime, have a great week.